Hey everyone, welcome to the webinar today. I'm going to give everyone a second to log in and then we'll get started. All right, I hope everyone's having a great morning or afternoon wherever you're joining us from in the world today. Welcome to today's webinar, co-hosted by the New York Oracle User Group and Oracle partner Viscosity North America. We've got two awesome presenters for you today, and this is a live webinar. So feel free to submit questions in the Q&A field, and both of our speakers will get back to you as they can or following today's content. If you are new to an NYOUG or Viscosity webinar, welcome. My name is Monica. I'm the marketing director here at Viscosity, and we are a full Oracle stack consulting firm that I'll tell you a little more about in a bit. But first, I'm going to hand it over to Coleman, who's the vice president of the New York Oracle User Group, and he's just going to tell you a little bit about them.
Thank you, Monica, for the kind introduction. So the New York Oracle Users Group was formed in 1984 for the exchange of ideas, assistance, and support among users of Oracle software products. Next slide, please. You can reach out to us on X, on Meetup, on LinkedIn, Facebook, and of course our website, nyoug.org. And just a brief announcement here. We have a few webinars that we're co-hosting with Viscosity. Starting on next Tuesday will be Apex with Tawfiq Mohammed. The second one will be AI with Paul Perlson of Oracle. The next one will be Sean Stacy. We'll talk about 23AI Vector. And finally, we have Mark Suits talking on August 20th about Apex AI. So I just want to thank Viscosity for co-hosting a series of webinars with New York Oracle Users Group since March of 2020 and continuing. Thank you, Monica.
Thank you so much, Coleman. And just a quick reminder to those of you who just joined us, this is a live webinar. We are recording it, so you will get access to the recording and any slides or resources our speakers decide to share with you after today's session. And you can submit questions live to the speakers in the Q&A field in Zoom. All right, awesome. So I'm going to just tell you a little bit about Viscosity if you're not familiar with us. We are a full Oracle stack consulting firm with core expertise in Oracle database. That includes RAC, Oracle Apex. We perform near zero to zero downtime migrations for our customers. We do a lot of projects with performance tuning and high availability, and we've got decades of experience with infrastructure, including engineered systems. So I'm super excited for you to hear from Ashish and Charles today about Oracle Exadata. On this slide, you'll see the three pillars that Viscosity is built upon: data, apps, and cloud or infrastructure. Across the bottom, you'll see things that we offer to all three of the pillars. So if you guys need any proof of concepts, training, managed services, definitely reach out and I'll put you in touch with our team. On this slide, I'd just like to point out a couple of our books. We have over 25 books, maybe over 30 books now with our consultants. But our newest ones are going to be on Oracle Database Performance Tuning, upgrading Oracle databases, and I think Oracle on Docker came out middle to late last year. So those are our two newest ones. Hopefully you already own some of these. And if not, we do tend to give a lot of these out at major conferences. So if you don't see us soon, check out what we've got at the next conference you're at. This slide, I just like to highlight some of my awesome coworkers and consultants to our clients. So these are some of our Oracle ACEs. If you're not familiar with the ACE program, I would highly recommend looking it up. But these are people throughout the Oracle community that commit to sharing their wealth of knowledge across Oracle technologies, and they do not work for Oracle Corporation. So it is like a title that Oracle gives them. But all of these folks here are published authors. They speak globally. They speak on digital platforms as well as in person. They got great blogs. You can follow them on X, all the things. They've got great content out there for you. And finally, AuraPub is where we house all of our webinar recordings as well as slide decks. We host virtual training here. We've got an AI bot that you can ask anything about Oracle performance, questions you may have. You should definitely check that out. His name is Shane AI, Surfer Shane. But you can go to aurapub.com, create a free membership, and have access to all of those tools. There are some paid tiers that have extra perks to them. I always recommend asking your management if they'd be willing to reimburse you for this, as it is great continued education. Okay, and with that, I'm going to turn it back over to Coleman, who's going to introduce our speakers to you today.
Thank you, Monica. So Ashish Ray is the Oracle Vice President of Products, Oracle Exadata, Database Cloud Services, Zero Data Loss Recovery Appliance, High Availability, and Scalability. His team is responsible for all technical product management and product strategy for Oracle's mission-critical database technologies, including Exadata and Database Cloud Services across on-prem, public cloud, and cloud at customer. Charles Kim is an Oracle ACE director, as well as a co-founder and president of Viscosity North America. Charles specializes in cloud, Exadata, rack, and virtualization, that being VMware, KVM, and Oracle VM. And Charles has co-authored 10 books around the Oracle ecosystem. Again, I want to thank Viscosity and for co-hosting these series of webinars for the past several years, and we look forward to continuing. Thank you.
Thank you, Coleman, and thank you, Viscosity. Thank you, New York Oracle User Group, for this wonderful opportunity to be in this platform. Both of you as an organization, Viscosity and New York Oracle User Group, have been very close technical partners with us. We continue to learn from each other, and you have been blazing the trail with regards to spreading the Oracle awareness and Oracle knowledge within our customer and partner base. So much appreciated, and we look forward to continuing this very collaborative technical relationship among all our organizations. So the focus of this presentation is what we have done recently with Exadata, pushing the boundaries on availability and scalability, and of course on performance. Very specifically, I will talk about Exadata ExaScale. This is a technology that we have just released. It's available in our public cloud and also on premises along with Exadata. What we have done with ExaScale is enabling what we are labeling as the world's only intelligent data architecture for cloud, which means we are enabling extreme performance for AI, analytics, and mission-critical workloads at any scale. What used to happen with Exadata, we have taken it to the next generation with Exadata ExaScale. And in this presentation, I will talk about the technical architecture, the differentiators, and some of the use cases. Many of you are currently Exadata customers. As you know, Exadata now is almost the de facto platform of choice for running mission-critical Oracle database workloads. Close to 80% of Fortune Global 100 run Exadata. And of course, Exadata Cloud Services are immensely popular also within our customer base. What we have done with Exadata ExaScale, we have combined the best of Exadata and the best of cloud in this new platform architecture. What does that mean? When you look at the inherent Exadata intelligence, this is what many of our customers love about Exadata. All the embedded intelligence that comes built in the platform. It could be intelligent OLTP, how we enable intelligent communication using hardware-based RDMA to deliver the fastest OLTP IO in the order of 17 microseconds between the database servers and the storage servers. We have driven this intelligence for analytics workloads also, how we can automatically offload data-intensive SQL to the storage cloud, and also for columnar analytics using very intelligent columnarization, where the optimizer automatically figures out that this workload, this analytics workload, is prime for in-memory columnar queries. And we can transcend these queries across both the database servers and the storage servers. And with the recent release of Exadata 24 AI software, along with Database 23 AI, we have driven the vector acceleration, the vector search acceleration with immense power, performance, and scale in an Exadata framework. So the core Exadata platform brings in a lot of this inherent intelligence that are very relevant to all these mission-critical workloads. What about cloud? The cloud deployment brings in other agility benefits. Pay per use, so paying only for the compute cores and the storage capacity that you may use. Inherently offer the cloud value through a multi-tenant resource pool, which means you can provision, deploy, and utilize any resource whenever you need them. Those resources don't need to be standing by. And hyper-elastic. You can scale up, scale out, depending on your rapidly changing business environments. With ExaScale, we have combined both these streams of benefits. All Exadata intelligence across OLTP, analytics, and AI, and all the cloud benefits across pay-per-use, multi-tenant resource usage, and hyper-elasticity now are combined with Exadata ExaScale. Let's look into the architecture, having set this premise. When you look at the traditional or the existing Exadata architecture, even in cloud deployment, every cloud tenant or every Exadata user, they have to use dedicated Exadata compute and dedicated Exadata storage servers. We have this very popular technology, ASM, Automatic Storage Management, and this is used to distribute storage across all the databases that would be provisioned across these compute and storage servers. What ExaScale does, it decouples this further. It disaggregates this further. If you think in terms of cloud, now with ExaScale, now we have a common pool of ExaScale resources. These are the compute and storage resources. And they are spread in our public cloud so that any customer could come in at any time and provision their workload with a select number of cores and select number of Exadata storage capacity, and just start off very small and scale up and scale out as they need. The ExaScale control plane in the cloud, it manages this automatic and load balance distribution of database workloads across these pooled storage servers. The users don't need to know about the storage servers or the database servers. Their interface are the VMs and just the storage capacity. Now this means in our cloud, we can harness the power of Exadata in a completely cloud manner to support thousands of CPUs for very mission critical workload, starting small and scaling out as needed. What are the differentiators of the way we have done this? If you look at how in cloud the storage architecture is laid out, or even the traditional storage architecture, there is a storage tier at the back end. But between the client applications and the storage tiers, there are these additional tiers, right? The load balancing tier, the storage metadata tier. And through these tiers, the storage is surfaced to client VMs as LUNs, which means any IO now has to traverse these additional tiers. And which means every tier now adds latency to the IO. For many of our mission critical workloads, these are unnecessary latencies. These are latencies that should be eliminated. Any bottlenecks should be eliminated. What we have done with Exadata, we have brought in the loosely coupled architecture, and we have integrated this architecture with the traditional Exadata benefits of SQL offload and RDMA. How does that work? So number one, Using this RDMA and loosely coupled network, ExaScale uniquely removes the need for intermediate tiers. In other words, for Oracle Database 23 AI, and mind you, Database 23 AI is a requirement for ExaScale, 23 AI client requests could send the IO request directly to this pool of ExaScale storage servers. And because these are RDMA done over 100 gig RDMA over converged network, this means with ExaScale elastic architecture, there is no need to have these intermediate tiers. And that's why we can enable literally microseconds worth of latency, even with millions of IOPS per second of throughput, by eliminating all these additional tiers and additional bottlenecks. And of course, what we have also done with ExaScale, leveraging the intrinsic Exadata architecture, we can do the auto tiering within the ExaScale storage cloud without any user intervention or without any systems configuration. This happens automatically based on embedded intelligence of database block IO inside the ExaScale storage cloud. So this means that the hottest data could stay in this pool of memory in ExaScale storage cloud called Exadata RDMA memory. Slightly warmer data could remain in this pool of flash cache inside ExaScale storage cloud, and the colder data could remain on disk. With this automatic storage tiering across ExaScale, plus RDMA, plus SQL offload, this means ExaScale can support immense amount of workload in a very cloud intrinsic architecture. And it can deliver this performance without any additional systems or configuration changes. Slightly zeroing in on the architecture. How does this work from a database IO standpoint? When we look at database IO and ExaScale, ExaScale will look at any database blocks in terms of 8 MB extents. Why 8 MB? We figured in our test that 8 MB is just large enough. It's just the optimal size to achieve good sequential performance. So for example, you would need this performance for analytic scans. And they're also small enough such that it can allow databases to be distributed across the storage cloud for ExaScale. So it serves the best of both worlds. Now we have defined this 8 MB extent IO for ExaScale. What's next? As I mentioned, these 8 MB extents need to be distributed across the ExaScale storage cloud. And this is done over a highly optimized hashing function. And the hashing function implements a mapping into a mapping table for each of these 8 MB extents. And each location of the mapping table is called a bucket number. So in this diagram, you can see the orange one maps to bucket number 1, the slightly pinkish one maps to bucket number 5, and the bluish one, the bluish greenish one maps to bucket number 8. So it can distribute these 8 MB extents using this highly optimized hashing function across this mapping table. And mind you, we talked about elasticity and fault tolerance. The mapping table also tracks the storage location of each extent, but in a fault-tolerant manner. So for example, the gold or the yellow extent now is mapped to 3 mirrors, but the client database does not need to manage it. It is all managed transparently. This fault tolerance and high availability is all managed transparently by ExaScale Storage Cloud. There is no client driver that is needed. There is no client configuration that's needed. All of this is done transparently. There is another thing about this mapping table. I talked about mapping table has a bunch of storage, has a bunch of buckets. Each bucket points to the exact location inside the storage cloud. Now, there are a couple of architecture decisions we had to solve. We had to come up with the optimum size of the mapping table. And this optimal size is fixed. It could be, for example, something like 100,000. Why 100,000 storage buckets? This size is just large enough to distribute this data across this like hundreds or potentially thousands of exascale storage servers in our cloud. But at the same time, this is also small enough by enabling this mapping table to be cached directly in the database servers or the database client's DRAM. And that facet is extremely important. The next couple of slides will address that. But another side note about this architecture, and it's very important to remember, if we can keep this mapping table size optimum, this means that as the storage cloud shrinks or grows, the mapping table size remains fixed, which means the mapping table does not need to grow, and the database clients automatically get the benefit of the storage cloud growth without going through any churn. In other words, ExaScale enables scaling of the data without scaling metadata. If you needed to scale the metadata also, that would have created bottlenecks in our architecture. And we eliminated that. We solved that problem. Let's look into further details. Remember, I said that the mapping table has to be small enough such that it can be cached in the client server's DRAM. So when the client database issues a block IO, maybe it's a read, maybe it's a write, because it is cached, it can automatically determine the location of the extent in the Exascale storage cloud and do a block IO using RDMA. Remember all the extra tiers and bottlenecks that Exascale eliminates. This is how it's able to do that. This is a direct IO architecture with no intermediaries, which means it's much faster. And this architecture is required for us to implement RDMA. Now you may ask, wait a minute, Ashish, what happens when the Exascale storage cloud grows? So when that happens, the client table or the client database in its DRAM simply refreshes the mapping table, the updated mapping table, and then can reissue the IO. Again, there is no application brownout. There are no application changes that need to happen. All of this happens automatically. This is how we are able to do hyperscale elasticity with Exascale with fault tolerance built in. And this is the big departure from our existing way to implement Exadata storage servers and database servers. This is a very unique differentiator of Exascale. And remember, I talked about intelligent data architecture for cloud. All of these technologies working in tandem in a unified manner enables this unified intelligent data architecture for cloud. Now you may ask, wait, like, okay, I get this benefit for Exascale for database storage. What about block storage? Can this be exposed as a block volume? Yes, it can be. So Exascale can be exposed as a block volume, which means underneath it can provide extreme performance IO for file systems such as ACFS or any other Linux file system. This also enables something very interesting. Because there are the RDMA benefits inherent, customer VM images can be now stored in the shared block volume. And this provides the foundation for some exciting capabilities that we are looking at for the future, namely around live migration for RDMA capable database VMs. So watch out for this space. in the future. And of course, because this is an exascale block volume, this can enable space-efficient, highly performant volume snapshots and clones for data on file systems, in addition to data in databases. And I will talk about cloning and snapshots for data in databases in a couple of slides. We started off this exascale journey when GenAI was taking off. And exascale continues this whole notion of how we can enable GenAI processing at amazing speeds, at amazing scale, and amazing availability. So in Database 23 AI, we have introduced this technology called AI vector search. With Exadata and Exascale, this entire AI vector search now can be transparently offloaded to smart exascale storage for much faster search. Again, there is no user intervention. What this means is, if you're querying based on your vector search, all these queries can be automatically parallelized across this pool of exascale storage resources. There are a couple of things that are very important to remember. Not only we are doing individual searches as part of the AI vector search, which can be transparently offloaded in a highly parallelized manner in exascale storage, we can also do the computation of the top K matches across this pool of exascale storage resources. And we can do inherent optimization such that we can have a running top K. With a running top K, we can avoid unnecessary top K computation in GenAI processing. So these are all very unique optimizations for AI vector processing that's only available with Exadata and Exascale that can enable up to 30x faster AI vector queries. And of course, because Exascale is a fundamentally a multi-tenant architecture, it supports the ability to do GenAI processing for multi-user environments by offloading thousands of concurrent AI vector searches in this highly scalable, hyper-elastic exascale storage. So that's GenAI. What I touched upon, cloning and snapshots, we have enabled that with exascale, and we have taken out all the current restrictions that are present in today's snapshot implementation. The number one implementation that we have done is we can do very storage efficient, storage optimized thin clones on exascale technology directly from the production database or directly from any other database that are still undergoing changes. There is no need to freeze the production database or freeze any test master database for read-only access. There can be transactions coming in the source database, and all the storage efficient snapshots and clones, they continue to be valid. Okay, so this means that this drastically reduces the storage capacity that you need for cloning. Number two, all the Exadata benefits are still available, including all the RDMA benefits, all the SQL offload, smart scan benefits. And number three, there are no restrictions, which means if you want to do dev test or recovery, but on the same level of performance as your production database, you can do that now with Exascale. There is no compromisation in the sense that, okay, I am doing dev test on a lower footprint platform or a lower scale, lower performance platform, and I don't have a good visibility into how this can scale, how this can perform when deployed in production. Exascale removes those restrictions. There are also some inherent optimizations that we have done. These clones, these snapshots, they can be distributed across the Exascale storage cloud, but at the same time, they can be distributed across the Exascale storage cloud, but at the same time, they can be distributed across the Exascale storage cloud, but at the same time, they can be distributed across the Exascale storage cloud, but at the same time, they can be distributed across the Exascale storage cloud, but at the same time, they are distributed in an optimized manner such that the storage efficiencies and the block IO efficiencies that are inherent with RDMA, they are preserved, which means we can do the distribution, we can do the storage optimization, but at the same time, even with snapshots, we can enable these hyperscaling benefits. And of course, this is integrated directly inside the database, which means inside the database, you can still use the commonly used SQL API. So for example, you can thin clone a pluggable database within the same CDB. You can thin clone a pluggable database into a different CDB. You can maintain a cycle of snapshots, for example, new snapshot every few hours. That's called snapshot carousel. And you can thin clone the entire CDB using GDB clone. All of these APIs work as usual, but now they are transparently integrated with ExaScale, which means all the ExaScale smart storage optimization benefits with snapshots and clones that are directly available at the database SQL level. Now you may ask, hey, what about data guard? Not an issue. You can do the same thing from a data guard standby, and you can create a data guard, a clone from a data guard standby into a test dev CDB. You can clone an entire standby database into a test dev. All of this works transparently with ExaScale. No restrictions, no limitations. What about the performance? What about some numbers? When we have measured these numbers in our labs, we are very happy to report that ExaScale enables amazing latency, 17 microseconds worth of latencies, which are amazing latency numbers that are geared towards supporting the world's mission critical workloads, where analytics and AI these days are increasingly real time. They are part of the regular online transaction processing workloads. And this real time data access, real time data management would not be possible unless the underlying platform, unless the underlying data platform can enable these low latencies. And we are thrilled to report that ExaScale can enable these RDMA-driven latencies at a very highly differentiated manner compared to what you may find in other storage clouds. With regards to throughput also, amazing throughput, because as you see, this is all hyper elastic. As you scale more ExaScale storage resources, it adds more storage capacity, it adds more storage bandwidth, it adds more storage co-processors, and it also adds more storage intelligence, smart scan, SQL offload, storage indexes, automatic storage IO tiering across XRMEM, flash, and disk. All of this contribute towards how easily we can scale out storage throughput and bandwidth compared to other providers. So we had talked about all the inherent ExaScale architecture, the differentiators, what led us to some of the design patterns. How can you take advantage of this? You can take advantage of this in two ways. The first way is using the Exadata database service in our public cloud on ExaScale infrastructure. And once you have a copy of this recording and the slides, please take a look at this blog link that we have published. With this cloud service, you're using the Exadata database service that is available today. However, today's Exadata database service involves dedicated database servers and storage servers. There is a minimal footprint that is required for you to start using this Exadata database service. However, with ExaScale, we have enhanced this service. Exadata database service now supports ExaScale infrastructure, which means as a tenant, as a customer, you can start very small. You can start with just a few cores and a few hundred gigs of database storage. That's it. And we have also enabled the Linux VM images to be stored on the network attached Exadata storage volumes, block volumes, which means we are abstracting the hardware boundaries for Exadata database service, Exadata database service cloud users. This makes it much more elastic, much more scalable, much more available compared to our dedicated Exadata database service today. And at the same time, what's very important is, give me a second here. What's very important here is, even with ExaScale, the immense IOPS that we are enabling with ExaScale, you are not paying for any extra IOPS. This is a big differentiator compared to other storage clouds. Other storage clouds, you can often see numbers such as IOPS optimized storage. No, we don't go through all these complications for ExaScale or Exadata cloud offerings. You get the best IOPS upfront. There are no compromises. But really what this enables is, it enables ExaScale availability and presence to a much wider variety of Exadata users. You can now start very small with a few cores, few hundred gigs of Exadata storage, and you get all the Exadata benefits: the SQL offload, the smart scan, the storage indexes, RDMA, the best IOPS, the best latencies, and all the built-in intelligence for GenAI offloads using ExaScale. And of course, as I mentioned, ExaScale is also available for Exadata on-premises starting this month. So take a look at this blog. It goes into details how you can leverage the ExaScale technology even for on-premises deployments as well. So the key takeaways of this very innovative architecture: Exadata, as I mentioned, is a de facto standard for mission-critical Oracle databases on-premises and in cloud. With ExaScale, we have taken this innovation one step further. We have pushed this innovation boundary one step further. We have brought in all the cloud semantics of a loosely coupled architecture. We have preserved the Exadata intelligent architecture, and we have extended this architecture across the power and performance of enterprise workloads with an extremely low cost, low entry point, affordable pricing point, scalable pool resources, and assuring agility throughout with fast database optimized, storage optimized, Exadata intelligent snapshots and cloning. This really means all Exadata benefits now are available for small workloads and small businesses. The differentiators are spoken for already, right? This is ExaScale now is Exadata reimagined for a multi-tenant hyper-elastic cloud. We have integrated cloud benefits with Exadata intelligence. If you look at the way we have deployed this architecture, we have designed this architecture, this is the world's only intelligent storage cloud. How we have pushed and distributed the database intelligence optimization across this pool of exascale storage and cloud resources. The world's only RDMA capable storage cloud that enables amazing latencies of 17 microseconds. Extreme performance, even for intelligent database clones. All the Exadata performance optimizations and storage optimizations are available with ExaScale snapshots and clones. And a shared pool of cloud compute and storage resources in a hyper-elastic manner can literally unleash hundreds of cores for any database query, enabling mission-critical analytics, AI vectors, test dev, all kinds of modern data management workloads. So that concludes my presentation. All information that I have talked about is available through oracle.com/Exadata. And we go through all the architecture benefits in our blogs. Feel free to take a look at those blogs and do reach out to us if you have continued product and technical feedback and questions on this amazing architecture. Thank you.
Thank you so much, Ashish. It looks like you have a question if you didn't notice that yet. And then we'll let Charles kind of get his slides up in the meantime.
Yeah, what's the question? Let me go there.
What are the controls in place if we have CloudStrike type bugs, and how do patching and upgrades work?
Yes, that's a very good, pertinent question. That's very relevant today. So with regards to controls in place, especially with regards to things like CrowdStrike, this is a fundamental way how OCI architecture, which is the second generation or the next generation cloud architecture, differentiates from the first generation cloud architecture. When we choose components to be deployed in our cloud, we have security built in every component, and that's specialized for the workload that that component is supposed to serve. Talking on behalf of database, we have strict security measures that are built in for access and for data access, for data manipulation, and for data controls. So that's number one. And number two, when such a thing happens, the question is how quickly you can resume business. So that's where we have our maximum security architecture integrated with what we label as maximum availability architecture. Fault tolerance and availability are completely built in, whether it's our Exadata database service or as you zero in all the components that comprise Exadata database service, Exadata platform, and Exascale platform. Any single component can be affected, but there are other fault-tolerant components available, and they will continue to serve workloads without any application brownout. And with the modern cybersecurity threats, especially related to ransomware, I would highly encourage our audience to look into this complementary technology we have, and that's called Zero Data Loss Recovery Appliance that's available on premises and also available in our cloud through Autonomous Recovery Service. Along with that, that adds an extra protection layer for any such rampant cybersecurity threats. So hopefully that answers this question. And Charles, feel free to add based on your industry practice knowledge.
Yes, awesome. You know, it's a lot of our customers on premise, they, just like you mentioned, they either use ZDLRA as a protection from ransomware purposes. We also have some customers using ZFS and the features within ZFS to perform immutable backups. And so, but the ZDLRA is becoming a lot more popular with our customers with Exadata. And that's mainly because you set it up once and you kind of forget about it. And Oracle just maintains all of that for you. Obviously, there's an OEM component you got to set up, but from a ZDLRA perspective, it is getting more and more popular. And also for customers who are going to cloud, we also strongly recommend, if you do need that level of high availability and you're concerned about ransomware, with few clicks, you can actually have your backups go to ZDLRA as well. So thank you, Ashish. That was great information on ExaScale. I'm going to go through a few slides in terms of why Oracle Cloud is so much better than the rest, and at the same time go a little talking about some of the stuff that we're working on. So for you guys who don't know, we do have a upgrading database book. It is written in 19C. As soon as the software is available for on-premise, we're not outside of Exadata. So if you don't know, Oracle Database 23 AI went GA for Exadata customers on-premise as well earlier this week, and also for Oracle Database Appliance. And we're in the middle of trying to, do that in our lab and to be able to update this book for 23 AI. But most likely, what we'll do is wait until 23 AI becomes generally available for the general public and update this for the release. Monica earlier mentioned our Shane AI. Our Shane AI is actually written with Oracle Cloud in mind. We leverage a lot of the Gen AI services from OCI. We have the capability to flip a switch, and this technology can go off of HeatWave or with autonomous databases. So we have that capability. And if you haven't seen it, it's really cool. It is written with a lot of the reactive and also responsive APIs. So it looks really well on the mobile app as well as your desktop browser. We demoed this at the Ascend conference in Vegas last month, and a lot of people tested it out, and the response was really good. Right, high level, what I'm gonna cover is going to be basically the AI stuff from an Oracle, Microsoft, and Oracle partnership, and a brief case study, and then we'll have a little Q&A with Ashish. And so let's look at what the CIOs are thinking about AI. This is a study that was done in 2023 called the State of the CIO. And as you can see, ML and AI from a 2023 perspective went up by 6% in terms of how much they are paying attention to this technology. Fast forward another year, another study done by CIO, State of the CIO. It looked at 1,126 respondents, of which 875 were leaders in that industry. And as you can see, the need for security went up
Charles, you're
significantly.
not sharing your screen yet.
Oh, shoot. Oh, my goodness. What's going on there? Okay. Share screen.
I see presenter mode.
That was good for a moment, Charles.
Yeah, sorry about that, guys.
It's okay. We were still learning a lot just listening to you.
There we go.
All right, there we
We're
go.
good now.
Sorry about that, guys. And so as you can see, from a budget perspective, CIOs are heavily invested in security, rightfully so. You know, as from a CrowdStrike perspective, we've all experienced a lot of delays in flights and whatnot. But briefly talking about CrowdStrike, I actually have customers running CrowdStrike on their engineering systems, where we've had some incidents with customers running cybersecurity software on Exadatas, and we strongly recommend not to run those on Exadatas, but we still have few healthcare customers who are really antsy about their data protection who are running them. And our general recommendation is to not install the software on the Exadatas. Going on, as you can see, there's a lot of attention being focused on AI. AI is probably the #1 initiative that all the CIOs have, but right behind it is that we need to focus on talent and maintain the skill set of our employees. And a lot of C-levels are concerned about that. Also, as you can see from 2023, AI learning has gone up by 55% within a single year. So even Oracle has a big focus in AI. And as you guys know, the name of the database product was renamed from 23C to 23AI. And as you can see now, from a lifetime support perspective and extended support perspective, 21C is now being supported until April 30th of 2025. 23AI itself is anticipated to go as far as 2032. And so when 23AI becomes generally available beyond engineering systems, a lot of customers are going to start jumping onto 23AI. And also, if you look at 19C, Oracle extended 19C support they gave all the customers basically 2 years of free extended support until April 30th of 2026. And if you look at extended support, it goes now up to 2027. All right, so 23 AI availability. In May, Oracle announced 23 AI availability for Oracle Cloud. And earlier this week, they announced 23 AI availability for Exadata and also for ODAs. And the exascale technology that Ashish did a great job explaining went live on July 9th in OCI. So today in OCI, you can actually provision exascale infrastructure and database. I've actually seen a couple of demos on this capability, and so far it looks amazing. And even with Oracle Cloud, once you provision a exascale database, they provide all the mechanisms for you to be able to create snapshots and clone databases. And there's a checkbox to say, I want to be able to clone this database as a thin provisioned database. And exascale makes all of that capable and easily available. Let's talk about the deeper relationships that Oracle is partnering with, not just Azure, but also Google. And so now we'll start with Azure. As you guys know, that Oracle and Azure have a very deep relationship. Now you can actually provision Exadata at Azure. And earlier this month, they talked about even doing autonomous Azure as well. And so it's available in 3 regions today, and obviously backups to ZDLRA is coming soon. Earlier this year, Oracle announced a partnership with Google, and it's going to be available starting in 11 regions. And later this year, they'll have all the bells and whistles that's available in Azure. From a cloud innovation perspective, if you guys attended overall last year, Oracle made a big emphasis on generative AI. Traditionally, in the past, it's always been speeds and feeds and new technological advancements in networking and hardware, but now it's a big focus on Gen AI. And if you look at what Oracle, from a driving focus perspective, is that, as you guys know, Oracle purchased a healthcare company called Cerner. And with Cerner, they are now in the healthcare space. And with it also, Oracle is now in the data space. And why play in the $100 billion market cap? As you can see, in 2024, Oracle did 52.5 billion in revenue, but the healthcare space is now 3.8 trillion in USA alone. And so if you look at their focus, Oracle is heavily focused on enhancing Cerner and putting in all the bells and whistles, especially with AI associated in the healthcare space. And so the big focus in Oracle Cloud last year was that we must generate to innovate. And I'm really excited to attend this year again in September. Hope that a lot of you guys are coming to Cloud World. We're doing our traditional meet and greet and also our cigar and bourbon events that we normally do. And so if you're planning on attending Cloud World, please let Monica know, and she'll be more than happy to send you invites. Also, enhancements beyond Oracle Cloud. In 2022, Oracle invested heavily in GPUs in terms of NVIDIA chips. And so now we have in Oracle Cloud 16,000 GPU clusters specifically around Gen AI. And obviously, if you've been following around a lot of the 23 AI features, beyond just vector data type and the ability for us to do vector searches based on comparing numbers now versus pixels in an image and whatnot. Now, with 23 AI, we have JSON duality, the ability for us to natively support JSON data types in Oracle. So For some of you guys who know Microsoft, Microsoft actually has a product called Hyperscale. And when I first heard Exascale, it reminded me of Hyperscale. Basically, Microsoft had this decoupling of storage and compute. But what they don't have is they don't have the Exadata in the back end. They don't have the smart scan capability. They don't have all of the parallelism that Oracle provides. On top of that, they don't have RDMA in the network stack either. And obviously, they don't have AI inside the database. And so Oracle's innovating in all three stacks. They're innovating at the hardware level with Exadata engineering. They're innovating at the software level with their AI components and also the analytics inside the database, and obviously in the cloud. There's a lot of networking that's innovations that's being made in the network layer as well. And lastly, Oracle is the only vendor out there that owns the hardware, the software, the cloud, and the network. And so in the future, I can see Oracle being a top contender in the cloud space. They're making little dents at a time, year after year, and a lot more innovations every year. Earlier, Ashish mentioned exascale with extreme performance capabilities. You're talking about thousands of storage servers, thousands of compute nodes. Now, from a smaller customers, customers have a very small entry point. You no longer have to commit to buying a quarter rack in Oracle Cloud or a quarter rack as an Exadata Cloud customer. Now, from an Oracle Cloud perspective, you can start with exascale with just 2 VMs, each of the VMs with 8 eCPUs and 22 gigs of memory. And then from a storage perspective, you can start at 300 gigs of Exadata database storage, and each of the VMs can grow in increments of 4 eCPUs, and you can add more VMs and add more storage at the gigabyte level or at the terabyte level. I'm going to actually go skip through some slides for sake of time. And we talked about from a storage perspective. And I just wanted to bring this attention because the Exadata storage is called 24 AI, and whereas the database is 23 AI. From an Exadata perspective, it's always leaped ahead of the database versions, but in this case, from a Exadata perspective, 24 AI is available for on-premise. It has been available for on-premise. Now the Oracle Database 23 AI is available on Exadata. See here. Case study. So I have one customer right now who is heavily invested in Oracle Database Appliance. They've been meaning to go to cloud for a while. And because of their high workload, they are not able to go to Azure. But however, they cannot afford to buy a quarter rack in Oracle Cloud. And so from a, excuse me for 1 second, folks. Sorry about that. So from a customer perspective, my ODA customer, they can't afford the Exadata Cloud and OCI, but this exascale capability can be a great fit for them. And for them, it's also they're 100% on Azure today, and from a multi-cloud perspective, it could be a great fit. Now, we just sold a ton of Exadata Cloud Customer and Exadata Cloud Service to a fitness management company, and they're currently on ExaCC today with ZDLA. And what we did with this customer, they were due for an Exadata refresh. They're currently on Exadata 8M, and instead of refreshing the hardware, we convinced the customer that if they gave up all of their Oracle on-premise licenses, they can save a lot of money by going to ExaCC on-premise with license included. And so with that in mind, they chose for financial reasons, they purchased Exadata Cloud Customer with elastic compute and storage, and give up all their licenses on premise and with Exadata with license included. And the next 4 years, they will save millions of dollars by going to Oracle Cloud. And customers today is heavily vested in Azure and AWS. And now, because of the savings that they'll have with ExaCC and ExaCS, they will now be vested heavily in OCI. And the future roadmap is to go with Oracle Cloud VMware solutions. And as you guys know, there are lots of customers having issues with VMware pricing, and we're working with them to migrate all of their VMware stack to.
Charles, did you want to share your screen again?
Let me go through some of the Q&A with Ashish. And so let's talk about who are your ideal customers for Exascale.
Yeah, Charles, that's a good question. As I mentioned, that ExaScale still has all the Exadata performance benefits, the scale benefits, the availability benefits. So all the mission critical workloads that Exadata supports today are all applicable to ExaScale. What ExaScale does one step further is open up through the ExaScale, through the Exadata database service, now on ExaScale infrastructure. It opens up ExaScale for smaller businesses, smaller workloads. So this means now customers with mission critical requirements, but with only a requirement of few cores or a few hundred gigs of storage, they can start. Previously, they needed dedicated storage servers, dedicated compute servers. So there was like a minimum start. So the entry point has become much more affordable. So it opens up to all kinds of customers, all shapes and sizes with these high requirements.
Awesome, awesome. Now, with the traditional database cloud service, where Oracle is a differentiator between all the other hyperscalers, Oracle is the only vendor who offers the database cloud service as a platform as a service, who also offers OS access. Will customers have OS access with Exascale?
Yes, yes. The underlying the question really is, what about the cloud service? So the cloud service still remains the same, which is the Exadata database service. And Exadata database service, as you know, enables the VM access to the customers. What happens with Exascale? The Exadata database service remains, but Exascale comes in underneath as an offering for Exadata database service. Now with Exadata database service, customers now have two choices: the dedicated choice, dedicated infrastructure choice, or the Exascale infrastructure choice. But the OS access patterns and the best practices, they all remain the same.
Great. As customers add CPUs or add additional storage, do they incur downtime?
No, everything is online. Otherwise, we would not be able to claim hyperelastic. It has to be online because we support enterprise workloads. They cannot afford to be down, and they will not be down with Exadata and also with Exascale.
And is that the same thing as if they need to downsize the CPU cores as well?
Yes, yes, absolutely.
Now, will this be available in Azure?
Yes. So what's happening is that's our long-term intention. So we are in active discussions with our cloud partners, whether it's Azure or whether it's Google, and all of this will be driven by customer demand. So this is something that we are considering with our cloud partners.
And obviously, is it the same roadmap for Google as well?
Yes. When I said cloud partners, these are active discussions with both Google and Azure, and watch out on the space for future announcements.
Right. And you mentioned earlier that this will be available for even on-premise Exadata.
It is available. So starting July, even like a few days back, our team made this launch available, made this release available for on-premises customers. So that will be Exadata 24 AI system software on database 23 AI. And we, in the slide, you will see I have a pointer to a blog which talks to more details about how on-premises customers can leverage this technology. So that's number one. And if maybe your next question is, what about the existing ExaCC customers? ExaScale with ExaCC, there is Exadata Cloud Customer is in our near-term roadmap.
And I know you mentioned earlier that only 23 AI will be supported. Will it ever backport to an earlier release for support?
Yeah, this is a fundamental architecture change, and this required very sophisticated architecture change in the database kernel code, along with Exadata system software. So unfortunately, it is not available as a backport to database 19C. It is available only with database 23 AI and beyond.
Gotcha. And I have one last question, because this is a stumbling block, has been a stumbling block for several of our customers. And we have customers who use GDB clone
Yes.
against a data guard environment. And they'll use a GDB clone to actually create a snapshot clone for data guard. And it works really well until the data guard or the we have to take the data guard out of snapshot standby mode and refresh.
Yes.
How will this work with this new capability?
Yes, so you're really pointing to a current restriction of Exadata snapshots today, where we say, okay, you can start snapshots from what's called a test master database, but the test master database has to be static. In other words, there are no changes coming to the test master database. And this test master database could be something like a standby database. And that's a current restriction in the sense that, okay, if you open up the test master database for read for write, it invalidates all existing snapshots. ExaScale gets rid of this restriction, which means that whether it's GDB clone, whether any other snapshot technology, whether it's PDB, CDB, the entire database, this database, the source database, there could be production side changes, there could be other test dev changes coming in, but all the snapshots that are supported by ExaScale, they remain valid. They remain valid, which means storage optimizations work. Redirect on write, which is the premise of our snapshot technology, they work. And all these underlying snapshots, they will get the latest updates that are happening on the master database, unless, of course, they have their own local copies of the writes. So it's all of this. It works as like a charm with Exadata performance and RDMA benefits. And also we have brought in with ExaScale some additional optimization benefits. So the snapshots of a particular file kind of like stay together, but also distributed across. So this works like really, really magically and amazing performance, even for test dev or any other snapshot related databases.
Awesome. Well, that ends my questions for you. And I don't see any questions in the chat. And I think with that in mind, I would like to thank everybody for attending today. Like Monica said, this is being recorded, and we will make it available for all the participants today. Thank you, Ashish, for your time. Appreciate all you do for us.
Thank you, Charles. Thank you for the opportunity, and thank you, Coleman, and the rest of the New York Oracle User Group team.
Thank you guys so much. And yes, like Charles said, this is a recorded webinar. You will have access to the recording and the slide deck at either www.orapub.com or NYOUG.org. So look out for emails from me or my team, or head over to NYOUG.org to find presentations like this. All right. Thank you guys so much. Thank you for giving us your Friday. Charles, Ashish, thank you as always for your expertise on engineered systems. Rob, Coleman, I hope you guys have a great weekend, and everyone else, take care. We'll see you at the next one.
Okay. Thank you, Monica. Okay. Bye-bye.